Hello everyone. I hope you people have seen lecture number 2. So we'll start with today class 12th chapter probability lecture 2 homework solution. So in the homework it was given to solve exercise 13.1 question number 9 to 17. Now we discussed question number 6th, 7th and 8th in the previous lecture. One part of question number 6 was left, which is the third part. So let us first write this sample space. In the sample space, when we toss a coin 3 times, the outcomes are head, 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 tail, head, tail, tail, head, tail, head, tail, tail, head, tail, head, tail, tail, head, head, and tail, tail, tail. These are the 8 outcomes possible when we toss a coin 3 times. Now event E in the third part says at most 2 tails. Okay, so at most 2 tails means maximum number of tails that you can have is 2. You can't have more than 2. So all the outcomes which have 0, 1 or 2 number of tails can be written. So we'll just exclude T, which means 3 tails. This will not come. All other outcomes will come because either they have 0 number of tails or 1 tail or 2 tails. So we should have maximum 2. So we'll write all those 7 except T. So I'm writing them. So these are the 7 outcomes that I have written for event E. Okay, let us write event F. In event F, they are asking at least 1 tail. Minimum 1 tail you should have, not not less than 1 tail. That means you can't have 0 number of tails. So only H is to be excluded, right? All other outcomes can come. Reason is at least 1 tail means minimum 1 tail. You can have 2 tails, you can have 3 tails. So except H, you have to write all the outcomes. HTH. As you can see in this, we have minimum 1 and 2 tails or 3 tails, right? So now the next one would be tail, tail, head, tail, head, tail, tail, head, head, and tail, tail, tail. So minimum is 1 tail and maximum we are going to 3 tails. Now let us find the common elements in these. Number of elements common to E and F. Except H. Just to see how many are common now. 1, 2, 3, 4, 5, 6. All these 6 I can see in this also. 1, 2, 3, 4, 5, 6. So this is not there in this E. In F part, HHS is not there. So there are how many? 6 elements which are common. In F, the total number of elements is 7. So number of elements in E intersection F divided by number of elements in F gives us 6 by 7, which is actually probability of E given F, which we were supposed to find out. So I hope this question is clear and everybody might have tried it at home. So you can match your answer from here. And now we will move to the next questions. So giving you some seconds to just correct your answers. Okay, now let us come to question number 10. In this question, as we can see, they are saying a black and a red dice are rolled. When we roll a die, the outcome are 1, 2, 3, 4, 5 and 6 only. Now we have to find the conditional probability of obtaining a sum greater than 9. We have to find the conditional probability of obtaining a sum greater than 9. So I'm considering one event E as sum greater than 9. In this, we have to write the outcomes in which sum will be greater than 9. In F, we have to write What is given event? Given event will become your F event. We have to find the probability of obtaining a sum greater than 9. That is, we are supposing event E, given that the black die resulted in a 5. So, black die shows 5 on it. Let us consider this as F event. Clear? So we are considering two different events. We'll find out number of elements common to them. We'll find out number of elements in F, and then we will find out P of E given F. That means probability of finding a sum greater than 9 given that black die has resulted in a 5. And we'll find the answer. Now see, in event E, sum should be greater than 9. So what I will do is, I'll write the event in such a way that the first one shows black die result and the second one shows a red die result. Now they are saying sum should be greater than 9. Sum will be greater than 9 with the events or the outcomes. I say if we see 5 comma 5, it gives us 10. 5 comma 6, it gives us 11. 6 comma 5, it gives us 11. This is sum more than 9. No other element will give us sum greater than 9. In F, black die is resulting in a 5. Black is the first one. So we can get 5 comma 1, 5 comma 2. That means the first one is fixed as 5. 3, 5 comma 4, 5 comma 5 and 5 comma 6. These are the 6 outcomes possible for event F. Now number of elements which are common are 5, 5 and 5, 6. So 5, 5, 5, 6 is here as well as here. So how many elements are common? 2. Number of elements in F is how many? 6. So probability will be number of elements in E intersection F divided by number of elements in F, which gives us the probability as 1 by 3. So this is how you're going to solve the questions on conditional probability. Here see, E and F were not mentioned. We have assumed one event as E, whose probability we have to calculate, and whatever is given, that will be considered as event F. Given that the black die resulted in a 5, that is to be considered as F. So this is how you're going to mention the events, find their possible outcomes, and get the answer for probability of event E given F. Similar way, you can solve the second part of it. Let us now move to question number 11. In question number 11, the first two parts are really easy to do, simple. We have to find out the third one now. In the third one, in the third part, this is the third part. In third part, so just to see, we have to find out P of E union F by G, or P of E union F given G has happened. The probability of this will be, or I should write number of elements. Number of elements in E union F intersection G divided by number of elements in G. So first of all, let us find out E union F. E union F. E union F means the elements which are there in E as well as in F. The same element is not repeated again. Like we see, 3 is there in E, 3 is there in F. That will be written only one time. So the even elements are 1, 3, 5 and 2. This is E union F. Let us find out G. It is already given 2, 3, 4, 5. Now, what is the intersection of E union F and G? What is common in them? The only common element is, I can see, 2 is common in both, 3 is common, 5 is common. So there are 3 elements common. So number of elements common are 3. Number of elements in G are 1, 2, 3, 4. 4 elements. So the probability of E union F given G will be calculated as like this. So it will be 3 by 4. Similarly, the AND part can be solved. You can go through it. Okay. Now let us move to question number 13. In question number 13, see what they are giving us. An instructor has a question bank consisting of 300 easy and true false. So I'm making a table kind of thing. Easy questions and they are true false type. So how many do we have? 300 questions. Okay. And 200 difficult question. They are also of true false type. So I'm making another row for difficult. And it will be written under true false type. So there are 200 questions which are difficult. So what was given in the first statement? 300 easy questions, kind is true false. 200 difficult question, kind is true false. Now 500 easy questions, so I'll write that in front of easy, but they are multiple choice questions. And 400 difficult questions, but they are of multiple choice questions kind. Now they are selecting a question randomly from this question bank. What is the probability that it will be an easy question? So let us consider E event as easy question. We have to find the probability of E, that is easy question. The condition applied on this is given that it is a multiple choice question. In F, multiple choice question will come up, and in their intersection easy and multiple choice. So how many total easy questions? I can see 300 and 500. There are 800 easy questions. Multiple choice questions are total how many? As you can see, they are total 900 in number when we add them. Okay, number of questions which are easy as well as multiple choice type are 500. So probability of E by F, E given F is number of elements in E intersection F, which is 500, and in F we have 900. So the probability is 5 by 9. So as you can see, you can just frame your data in form of a table to make it easier for you. Write down whatever is given and then put the values in the formula. You'll get the answer. It is important to note what is to be coming in the denominator part, right? So whatever will be given, whatever is happened already, has occurred already, that will come in the denominator part. So I hope this is clear now. Let us move to question number 15. In question number 15, okay, this has been repeated also in CBSE. Pay attention, see they are saying, consider the experiment of throwing a die. So I am writing a die is thrown. So what will come up? 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5, 6. These are the outcomes. Now, what are they saying? If a multiple of 3 comes up, so I am writing the multiples of 3 only. Multiples of 3 out of these 6 are 3 and 6. So if 3 and 6 comes up, you have to throw the die again. If this comes up, you will throw the die again. You will get 1, 2, 3, 4, 5 and 6. Okay. Now if any other number comes, that means other than 3 and 6, 1, 2, 4 and 5 comes. What is to be done? A coin is to be tossed. So you may get head, you may get tail. Yes, so let us first write down the sample space for it. With 3, we can get 1, we can get 2, we can get 3, we can get 4, we can get 5, and we can get 6. Because when we get 3, we will roll a die. Also, we can get 6, 1 up to 6, 6. Also, with 1, you may get head, you may get tail. Similarly, with 2, you may get head, you may get tail. With 3, with 4, you can get head, you can get tail. With 5, you can get head, you can get tail. So these are the outcomes. So total I see 6 and 6, and these will be 8. So total 20. In the sample space, you have 20 outcomes. Fine. Now, We have to find the conditional probability of the event. Coin shows a tail. So one event will be coin is showing a tail. Consider that as E. Coin shows tail. Second event F, where it is saying given that at least one die shows a 3. One die shows 3. Nope, just pay attention here. When you will be finding E intersection in this. E intersection means coin will show 3 and die has resulted in 3. But as you can clearly see, if 3 comes, you are going to roll a die again. With 3, you will not get head or tail. It is not possible. So number of events that are common is 0. So the probability for E by F will also be 0. Clear? It is not possible that the coin shows a head or a tail with 3, because with 3 we are not tossing a coin. When 3 comes out, that means a multiple of 3 comes out, we are rolling a die. So probability would be 0 in this case. Okay, let us now move to the next question. Question number 17. In question number 17, they are giving us that A and B are two events such that P of A by B, P of A by B is equal to P of B by A. Okay, now in this one, they have given us four options A, B, C, and D. This is A option, B option, C option, and D option. So which one of them will be the correct one? So let us solve this, the given part. P of A by B. E given B means P of A intersection B divided by P of B. The next one will be P of B intersection A divided by probability of A. Now as you can see, P of A intersection B and probability of B intersection A are the same things. So the numerator parts are equal, right? Now, if this is equal, this implies what? That P of A is equal to P of B. Then only these two things can be equal, right? So according to this, option D would be the correct answer for this. So that's all for your homework solution. We'll see you in the next lecture. Bye.